Many of us technicians continue to struggle with electrical troubleshooting. Perhaps it's the unlimited number of ways the circuit we're trying to diagnose can fail. But what if I told you there's really only one way that a circuit can fail? Would that make troubleshooting easier? I have someone I'd like you to meet. His name is George Ohm, and the answer to my question rests within Ohm's law. Ohm's law states that current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points. The law also introduces us to the concept of resistance, which is something we understand as the opposition to current flow within a circuit. If you don't remember the wording, I'm betting you also don't remember the equation that represents Ohm's law. Quite simply, V, or E, is typically used to represent voltage. I represents current, and R is used to symbolise resistance. And this is the answer to understanding all electrical circuits and their troubleshooting. Ohm's law is all about the relationship between voltage, resistance and current. When an electrical circuit isn't working as it should, it's likely due to a change in one of the three. But before we talk about the relationships between them, let's review what each term means. To get the electrons moving, there has to be a source of imbalance, or a difference in electrical potential, which will force the electrons from their host atom. A battery is a great example as a source of electrical potential. On the negative side of the battery, there is an abundance of electrons, or a high potential, and at the other, a shortage, or low potential, which is caused by the chemical reaction occurring inside. Voltage is the measurement of the difference in electrical potential, in this case, between the positive and negative posts. If we were to attach a wire between the posts, the electrons would have a way of getting from one side of the battery to the other. The movement of those electrons is the definition of current and is measured in units called amperes or amps. Have you ever accidentally arced a wire or tool across the posts? Do you remember what happened? As you can see, the wire quickly overheats and burns through. This is because the wire offers very little opposition to electron flow. The resulting high current causes an excess of heat within the conductor. That opposition to current flow is called resistance and is measured in ohms. Anything that resists or slows the rate of current flow is said to be a resistance. Now that we understand each element of Ohm's law, let's focus on the relationship between the three. Here's an example of a basic lighting circuit. Nothing fancy, just a light bulb, a battery, and the wire needed to complete the path between the two. The battery is the source of voltage in the circuit, and it should remain relatively constant at around 12.5 volts. The bulb is the reason we even have a circuit. We use electricity to do something. Any device performing work in an electrical circuit is referred to as the load. The load is a key element here. This is the resistance in the circuit. According to George Ohm, it's the constant that will determine the actual current draw. Whenever we are diagnosing a fault in an electrical circuit, we are diagnosing a problem with the load. In the vast majority of instances, the only reason any load doesn't work as it should is quite simple. The current flow is not what it should be. This means that if something happens to the circuit voltage or resistance, the current flow will change. Ohm's law says so. If the current in the circuit changes, it will impact how the load operates. These points need to be remembered. You can easily access them via the resource attached to this module. If voltage in the circuit increases, current flow will increase. If the circuit voltage decreases, then so too will the current. If the circuit resistance increases, the current flow will decrease. And if the resistance in the circuit decreases, then the current flow will increase. Let's apply this to our simple lighting circuit. The problem we see is a dim globe. This must be caused by lower current flow than required. So, what could have happened to cause the reduced current flow? Based on what we know about Ohm's law, either the voltage to the circuit went down or the resistance in the circuit went up. This is why, when diagnosing any electrical complaint, we must verify the health of the battery and charging system as a first step. Always take the source voltage element away from the concern. And while this will solve some customer concerns, most of the time the problem will be caused by the total circuit resistance. This resistance may occur in the load itself, like a burnt filament in the globe. What would change in the total circuit resistance? Of course, it would be an open circuit, and the resistance would measure as infinite. So, what happens to the current flow? It drops to zero, doesn't it? Let's take a look at another example. What if the wire from the battery to the load breaks before the load and touches ground? What's the circuit resistance now? Zero, right? So what happens to the current flow? It keeps rising until the wire burns through, or the fuse blows. One more example. What would happen if there was corrosion in the bulb socket? How would that affect total circuit resistance? Simple. It would add resistance. So what then happens to the circuit current flow? It decreases and the light appears dim, or it doesn't operate at all. So, the next time you're facing an electrical concern, remember, we can lay the blame on George Ohm. The relationship between voltage, current and resistance is foundational knowledge, and mastering this will help us solve more electrical concerns.